Today's talk will talk about the large-scale cluster management and recovery for the multi-DC-based Solr cloud. So first of all, we'll talk about the challenges we faced at BloomReach. Basically, we serve multiple tenants in the same Solr cloud platform and with hundreds of millions of documents. And also, some of the apps requires high availability and very low latency. And also, some of the apps we basically don't afford to have any downtime. And so the basic idea is to create another layer to abstract the management layer for the Solr cloud, so that we can easily to deploy the new data center and recover from failure. And also we can monitor the performance of different data centers. So about BloomReach, as we are the cloud marketing platform, our customers, majority of the customers are from retailers, and we'll help them for their content to get found over the web. And Nitin and me both work at the search platform at BloomReach. Nitin is the lead engineer, and I'm the member of technical staff. So at BloomReach, we have basically three products or three applications. One called organic search that will basically to enhance the possibility of your content to be found over the web. Another product called Snap, which is the customized search on the retailer's website. Suppose you go to Neiman Marcus, you search for some products, then which product shows up or the rank of the product is controlled by us. Compass is another new product that will take all the user search data, analyze that, and propose to the customer for better content. Today's topic is mainly about Snap because every retailer's search, every retailer's search will hit our Solr cloud directly, and we cannot afford to any downtime, and the latency requirement is very high. So last year, we mainly present Solr cloud, compute cloud infrastructure, basically for the organic search product. That idea is we want to isolate the write, the indexing directly to Solr cloud. So we basically use a so-called SC2 service. Whenever you want to write to Solr cloud, we'll provision a elastic cluster, which all our infrastructure is AWS-based. So we just provision the spot request. And then you index to that spot request our halved API. The halved stands for high availability and fault tolerance, will replicate the index from the spot cluster to the backend Solr or serving Solr. So that's the main idea of last year's talk. And the Snap is a relatively new product, and it was on the old platform. And this year we integrate into the same platform. But as I mentioned, and also like last year we promised the half API will be open source, and we just open sourced the half API before we come here. You can find the API on the GitHub under BloomReach folder. And also for the recovery part, we basically use, we copy the Zookeeper data. We can copy the data center from one data center to another data center. So we also open source another set of tools called Zookeeper Replicator. If you are interested, you can also take a look at that. And so talk about the challenges we faced for the Snap products. Because the functionality I mentioned, for all the retailers, they have their own defined rules of how they want to rank the product. So, and also the out-of-box Solr cloud cannot fulfill the requirements that we want to somehow to trace the ranking, calculate the different field, or the boost different field. So we have the customized component inside Solr cloud, which will boost in the same JVM. And also we have the global ranking for all over across the Solr cloud for all customers. And for per customer level, we also have different every customer has their own ranking files and also their ranking configurations. That is per core based. So the challenge is for the customized Solr cloud, because it exists in the same JVM, if something wrong with the code, there will be something wrong with the code. And either JVM just blow up, the memory usage is very high, and Solr becomes unresponsive. And for the global ranking configuration, if some misconfiguration, then Solr just won't start. And for the collection level based entities, we have the ranking files. So the ranking files it's the customer provides ranking files. Basically, they upload through our API, and our API just upload the files to the Solr cloud. But for some customers, they will give us very large ranking files, which will again consume the memory. Also, for those external files to Solr cloud, even you share them, it doesn't help too much in terms of memory because they still need to exist per core. So when they load up, they will load to the memory. The ranking file config per collection also, it will not corrupt the entire Solr cloud, but if there is some misconfiguration, it will corrupt the core, the Solr core. So that's basically just what I described. If there is a bad jar deployed, Solr just become unresponsive. And at that time, when you want to restart Solr, and the version we use is 4.6, sometimes if the number of collections is too large, there will be some either race conditions between Zookeeper and some cores will be down. But for us, there shouldn't be any downtime for any core. Also, that's the large file I mentioned earlier for the ranking files. And that's the challenge we are facing. And also, as I mentioned, we have 3 different products. And also for example, one customer may have all 3 products, but their purpose of the products is totally different. For example, for organic search, we basically generate the page data in the Solr index. And that index will be quite large, but it's not frequently queried. And for the Snap, the number of documents is huge, but the size is not huge, but the latency requirement is very high. So for every tenant, they tend to have different purpose. So we define the tenant as a collection, a Solr collection, but the collection should have the ability to provide the serving purpose, which app you want to serve. And because of that, recovery strategies are different for different apps. For example, for Snap, when you recover a collection, you are not only need to recreate the collection, but you also need to copy all the correct data, the config data, to the cores. But for organic, because there's no customized component, there's no customized external files, basically you can just simply recreate the collection, copy the data, and it's fine. And also, we also facing the multiple DC challenges. So for us, our customers not only in the US but also all over the world. So for example, if we launch a UK customer, they want to serve both from US and Europe. So the traditional approach is that you just link all the data centers to one Zookeeper so that the replica will go on. But it's very hard to maintain, and if the Zookeeper goes down, basically all your data center goes down. So as I mentioned, all the problems, and we proposed a data center-based management. The data center is not the traditional infrastructure data center. It's a logic unit, a logic group of Solr nodes and Zookeeper nodes that represent either one application or several applications. And Solr cluster is a group of Solr data center, which you can imagine. For example, you can have the organic data center, organic US data center, organic EU data center, and Snap US data center, and Snap serving data center, Snap backup data center, Snap preview data center. They all inside the same Solr cluster, you can have multiple clusters. One's for production, one's for development or customer integration. And also the replication API is the cornerstone for all this to happen. Because as I mentioned, the previous year's presentation, we basically heavily relied on we index into the Spot request AW cluster and then replicate back. And also the replication API will play a huge role on how we recover from the failure. And also another API, as I mentioned, when customer want to upload their customized ranking files, they go through the ranking file management API. And for the definition of Solr data center, basically for us, this is a JSON file representation of a data center. You can see you can define what region the data center is in and how many Solr hosts it should have, how many Zookeeper hosts it should have, and what's the role of the data center. Basically, you can define if it's a serving data center or not. If it's a serving data center, we tend to put all the serving data center under ELB, and basically, so the customer just query the ELB, not directly to the Solr cloud. And also, you can have the backup data center or preview data center. You can also specify what apps it's in. It's in either Snap or Organic, something like that. So this is a full picture. Basically, on the left hand is our cluster, Solr Cloud cluster, and right hand is our abstract management suite. And in the Solr Cloud cluster, you can see all the serving data centers. They connect to ELB, and that's for facing customer queries. You can also have other different data centers like backup, preview, and other regional data centers inside the same cluster. All the operations and like replication, like create Spot request cluster, all go through the management APIs. So no one goes to the Solr Cloud directly. They must go to the management API. All the management API will break up for different services. All the services play framework-based HA setup. Basically, all the service is high available. And we store all the data center data I mentioned before in the JSON file to a backend cluster metadata. We currently use MySQL RDS, AWS RDS to store the metadata. And I will walk through all the services we have right now. The last one, auto recovery service, is building right now. It haven't completed yet. So for the replication API, as I mentioned, we have a production Solr cluster, and that's right-hand side is electric class indexes, which basically just a Spot request cluster we created from the production cluster. And when they finish index, they want to replicate the index back. Basically, the indexers will just tell us, I want to replicate back Snap application to which cluster, the production cluster or development cluster. And the replication API will go to the cluster metadata database to figure out, suppose you want to replicate back to Snap, right? And I figure out how many data centers in the cluster has the role of replicate. So in this example, because all the backup serving has the role of replicate, so it just goes replicate all the index to all 3 data centers. And same thing for the ranking file management. So for ranking file, because ranking, as mentioned, ranking file is used for the customer to define their own ranking algorithms. So that will only be put into serving cluster. Backup cluster, basically we use backup cluster, backup data center as just purely for data backup. So for the ranking pipelines, once the customer want to upload the ranking files, they will tell us which collection they want to upload, and also the same, which app. And we'll figure out that for that app, the 2 serving data centers are required to have the ranking files. And after upload to the serving data centers, we also put a version on the files that serves the purpose for the recovery part. we store all the upload files on S3. So later on, if anything happened, we want to recover, we can copy the files from S3. Also, all the replication and ranking files upload, we put all histories into database. So later on, if anything happened, we can track the execution of all the APIs. And another service is called deployment and recovery service. So basically for the deployment service, as I mentioned, suppose you already have existing clusters and you want to add the capacity into the cluster. Suppose you want to add a new geo-based data center, just like us. When I came here, we want to launch US West data centers. So you can just simply add to the cluster. Or the holiday season is coming for us, so the traffic will go up. So we plan for the holiday seasons, we just want temporarily add a new serving data center. So basically, with the deployment service, it's easier to do that. You just need to provide the data center JSON, as I mentioned before. You just specify, I want a serving data center 3 with how many machines and what application it should come serving. So the deployment service then will talk to the cluster metadata and to store the config to the database. And then it will provision, because we use AWS, it automatically provision all the Zookeeper hosts and Solr hosts, and install Solr Zookeeper on the host. That's just a bare installation. After that, the deployment service will figure out where should I get the index and configs. So it basically, in this diagram, it just fetch the index, copy the index from backup data center and the config files from the other serving data center because they serve the same application. And then it's done, and we will do a smoke test. Smoke test, basically, we test every collections in the data center with other, compared to other data center if the query result is same. And only after that, we'll add back to load balancer. So there's no manual launch instance involved. It just provides the data center JSON, and everything will be done automatically. That's the example of the JSON file again, how many nodes in the data center and what's the load balancer endpoint. Another useful case for that is a hardware failure. Because we use AWS sometimes either they retire the instance or they have their own network issue. So our cluster, the data center basically is down. So in that case, it's similar to how you launch a new data center. The difference is that you don't need to specify the JSON file anymore. Suppose you have a serving data center 2 is down, and the deployment service will just retrieve the existing config of the serving data center 2 from the database and provision the host for you automatically because it already has the configuration of how many hosts and which app it serves. And then it just, how you launch a new data center, it will launch a new serving data center 2 and do the smoke test, swap with the existing serving data center 2, add back to the load balancer. So the hard recovery is also easier to do. And another failure is for the software recovery. As mentioned, if you deploy a bad jar, and basically the JVM just go out of memory and you are done. So and also for us, because the customized component, our current schedule is to release the customized component every week. And out of the box, Solr, the Jetty, we use Jetty, and it cannot do the hot load of the jar file. So we must reboot Solr. And the soft recovery also used for that. So before going to the soft recovery, I'll briefly talk about the snapshot we do. Basically, as I mentioned before, all the config files, the per collection level config files and the jar files existing outside the out-of-box Solr, we want to track the usage of them, to take snapshots, so for us to be able to quickly back it up. So basically, we just use the Half API to figure out, for example, we'll take a snapshot of serving data center 2, which will have the global files of the jar file and global config. and per collection level config of the ranking files, and put them to S3 with a timestamp-based folder. So later on, when anything happens, suppose you release a jar today, 8 hours later you find out your memory is out of control, then you can just basically revert back to the snapshot without figure out which jar you should need to use. And this is the simple UI for that. Basically, when you want to revert, you just put the realm basically means the cluster's name and data center name, and the path of snapshot. It will just automatically revert it back. For us, the index is different because we promise our customers the index will have their newest products, right? So we cannot revert index. Otherwise, the customer's newest update will not be reflected. When their customer doing the search, they will not get the refresh result. So that is unacceptable for them. So we only revert back the external files, not the index. So this is talking about the self-recovery used in the code deploy mode. So basically, once you want to deploy the code, we'll take a lock on the data center, so to prevent others working on the data center. And also, the diagram didn't show that once we took the lock of the data center, we put the data center to maintenance mode, so the replication and the config upload will not go through it. Otherwise, it will sometimes it will fail. And we take the serving data center out of load balancer, but still have one serving data center remain in the load balancer. So the customer serving traffic will not be affected. And then we deploy the code. Basically, the code is just copy the jar files and the global configs to Solr Cloud. It's automatically figure out like which data center it should go into. And then it's same thing after we do the smoke test. We put it back to load balancer and release the lock, so the serving data center can be served again. And during the maintenance window, all the replications and config upload will be put into a queue. So at the end of the recovery, we'll just recopy all the index from other data center, and all the config upload, because it's in S3, we copy that from S3 back. And another use case is basically suppose you deploy the bad jar, and immediately you find out one of the data center is unresponsible. So basically what we did, the recovery service will automatically get the global lock and take the data center out of load balancer, so it will not affect the serving traffic. And the first will do a rolling restart of the all the Solr hosts. If the size of collections is not big, normally it will succeed. And after that, we'll do the same smoke test, check off the index and the configs. If it's passed, we'll just add back to load balancer. If it's not, the service will just wipe out the data center. By wipe out, I mean it will delete all the installations of Zookeeper and Solr on that data center. So basically, it's just a bare machine. And then we'll just reinstall Solr, Zookeeper, and the collections are copied from the backup. The index are copied from backup data center, and it's same thing as how you launch the new data center. The config copied from the S3. That the screenshot is the progress. Once it creates the collection, it will report the progress, how many collections has been created, and after it's done, it do the same test and add back to load balancer. So that's the soft recovery part. As I mentioned, like the Snap app, they require the high availability, so we built an active monitor service around it, so we can know the failure before, or should be before it happened. So the active monitor has 2 levels of service. One is a node level. Basically, the active monitor will go to every node, just ping the node to see if the node is accessible and all the collections are queryable or not. That's just a basic check. If the node is down, it's like suppose you have a data center have 5 nodes, and 2 of them is down, or 3 of them is down, it will page us for now. Like I will mention later, we plan to build auto recovery service that automatically do the recovery for you. And we also use semantics to monitor the JVM usage and CPU load, also the heartbeat from each host. And we also have a cluster level monitoring because, as I mentioned, we have multiple data centers. We need to ensure that every data center in the same serving applications has the same index, same configs. So the active monitor basically goes to use the Have API. It gets the Zookeeper configuration and talk to the Zookeeper, gets the Zookeeper's cluster state. And then from the cluster state, it goes to every host to check if on that host the config file are same or not, the index are same or not. If it's not, right now we just raise a pager. It runs every 5 minutes and checks the data across clusters. What we are planning to build is because if you look back all the events, it's pretty much almost all the events are auto-recoverable. Because, for example, if one Zookeeper node is down, you don't need to pay. Just the auto service should be able just to restart that Zookeeper and check if it's accessible. If one Solr node is down, you can also do a restart. If the cross-cluster check was serving data center 1, serving data center 2 have different index, basically the auto-recovery just should replicate again from backup data center. And if serving 1, serving 2 have different versions of config files, because we version every file on S3, the auto recovery service should be able just to resync the files from the S3. And if the JVM usage is high, suppose you deploy the code, and 8 hours later the JVM, the origin usage like about 90%, then here you can basically have 2 choices. If it's just recently deployed new code, right? You just roll back to the previous version. And if it's unclear, because for example, if it already deployed the code for 2 days and all of a sudden a JVM issue happened, the first thing you can do is just to do a normal software recovery. It will recover of the current state, but it will not roll back because you don't know if it relates to the code deployment or not. So that's our plan. If any of the serving machines is down, you basically just cannot telnet to it. You just do the hard recovery. So from our point of view, everything should be auto-recoverable unless if something wrong with our recovery service. So that's all for my talk today.